So on 20, you're presented with something that's pretty interesting. What might you try to do first? What's one thing you might try to do? U-sub. Does U-sub work? No, it doesn't. What's another thing you could try? Simplify, sure. Can you go anywhere with that? No. You might recognize something. Yeah, you might think to yourself, what?
Tan inverse.
Tan inverse. You do know that the integral of 1 over 1 plus x squared dx is what? Tan inverse x. But the problem, what's the problem with noticing that?
The 1 does not equal sin x.
Yeah, there's a problem with that. That changes the whole thing. You can't just do that, right? Okay. So if you run out of options, what's the last thing you could do? Someone said it over there. Graph it. So if you graph this thing, how would you go about proving it is 0? What? It's an odd function. Good. Very good. One thing that you need to know is if you integrate from negative a to a of an odd function, it's always going to be 0. It's always going to be 0. Does anybody know why that's true?
Because it reflects over the origin.
Yeah, so what it means is, what is the definition of an odd function? F of negative x is equal to what? No, negative f of x, right? So for every little rectangle, say, for example, right here, there's the exact same one going below the x-axis right there. It nukes itself out. Does that make sense? Similarly, what's this? If you go from negative a to a of an even function, what does that equal? 2 times the integral from 0 to a of the even function, right? Exactly. Good. Good. Yeah, let's make u is equal to x squared minus 4. So what does du equal? 2x dx. So dx is equal to over 2x. So what do you end up with? The integral x over u times what? 2x. And what's the magical thing that happens now? That's awesome. And what do the limits of integration become? Negative 3 to what? To 96. Thank you. Yes. So you get 1/2. I don't know where 96 u to the negative 1 du. What's the integral of u to the negative 1?
There's a problem.
What's the problem?
You're talking
Let's see what happens. So yes, hold on a sec. Let's just do this and see what happens.
no, like I did this. But
Yes,
that's what
I understand. Let's get there so everybody else can understand what you're saying. So what does that mean? What is the integral of u to the negative 1? What? ln of what?
U.
Absolute value of u from
96 to
3 to 96, and it's times 1/2. So what's it going to be? It's going to be 1/2 of ln of 96 minus ln of 3. Correct. So yes, if you do this, you get 1/2 of ln of 96 over 3. You can write it like that. Now, Mariah, do you have something to add about this question?
that you should be really careful when crossing asymptotes because you get some as it goes closer to the asymptote.
What asymptote are you crossing on what function?
Well, with the ln, you're
No. What is the integral of 1 over x dx? ln of the absolute value of x. You need to have that absolute value in there. You must. Just remember that. Whenever you take the absolute value of 1 over x, sorry, the integral of 1 over x, you get the natural log of the absolute value of x. You have to do that way. Have to. Correct? So you end up with 1 over pi sine u cosine u du. What now? Again, this is not differentiation, it's integration. Could you do this as 1? Yeah, you could have just said u is equal to sine of pi t. And does it work really nicely? Yeah, because the cosine goes away. Yay. Awesome. Can you do repeated substitutions? Sure. But this is an indefinite integral, so you have to resubstitute at the end. You can't leave it in terms of p because, yay, the answer is 1/2 p squared times 1 over pi. No. The answer, you have to resubstitute again. Does that make sense? How would you check this? Yeah, take the derivative, exactly. It works. It's good. You did well.
yes.
So yeah, the key thing was, the one thing that was different, I like that you picked this one, is because you have two dx's here, but you want to isolate dx, so you just factor it out. So that right there is the difference, but it doesn't change it by too much. The answer was x squared plus 4x to the 1/2. Let's see, yes. Plus c, thank you. If you've ever done an integral, you know, you've done this integral. Oh, that's not what I want. You've done the integral of 1 to 2 of x squared dx. What is that actually? That's the integral from 1 to 2 of x squared minus 0 dx. 1 to 2, thank you. 1 to 2, exactly. So there's that invisible 0 that's been there every time, right? So for example, I could give you a function. There's an upper function, let's say g of x, and a lower function that's a little bit more exciting than the x-axis. You know, if you go like this, there's f of x. I could ask you for the area of this space right here. Let's say that's x equals a to x equals b. What would be the integral expression for this area right there? What would that integral expression be? A to b of f of x dx. Exactly. Very good. G of x minus f of x dx. That's it. All you're doing is creating a new function. That's it. What's really the only thing you have to be careful of? Well, let's look at a few of the questions. This one here, it says, find the area of the region bounded above by that function, below by that function, and bounded on the sides. When it says something is bounded above, and it gives you the limits, you can assume that it's going to be above the whole time. So for this one, can someone tell me what the integral expression is going to be for this first one? The integral from 0 to 1 of minus dx, because the lower function is y equals x. Do you feel comfortable in integrating that? It's about as easy as it gets, about. Now the second one gets to what Eli was talking about. Find the area of the region enclosed by those parabolas. So what are you actually going to find? You need to actually find the intersection points and think about what this looks like. Sketch a graph. The easiest way to get something like number 2 wrong is simply, honestly, is to totally mess up your visual comprehension or what you're thinking of what this looks like. So you have y equals x squared and 2x minus x squared. Should you be able to graph those pretty easily? Hopefully. There's y equals x squared, right? What are the zeros of 2x minus x squared? What's one of them? 0 and what? 2. It goes like this. So what's the area that's enclosed? The area that's enclosed is right there, correct? This one is y equals 2x minus x squared, and this one is y equals x squared. So what's our first intersection point? Well, our lower limit of integration is going to be what? 0. Our upper is going to be, you have to find the intersection of the two. X squared equals 2x minus x squared, so 2x squared equals 2x. So x squared is equal to x, so what's x going to be? Plus, well, actually, you're right, yeah, 1 or 0. Exactly, we already have the 0, so what's this x value right here? So this integral goes from 0 to 1. The upper bound is going to be 2x minus x squared, and what's the lower bound going to be? Complete the brackets and dx, you're done. Is that pretty simple? Yes, it is. It's meant to be simple. The hardest part about these is generally setting them up. Setting them up. Here's another danger. Take a look at number 3. Find the area of the region bounded by the curves y equals sine x, y equals cosine x, x equals 0, and x equals pi over 2. Make a sketch. Do that right now. Make me a sketch of number 3. Make me a sketch across the y-axis. 0. Good. So we do this, and we do this. Yay. So sine looks like this, right? What does cosine look like? It goes down a little further, right? I'm freehanding this. Like that, right? And you're going from 0 to where? Where is pi over 2?
It's where cosine is first.
It's right here, correct? That's x equals pi over 2. So you're going from 0. So what region are you looking at? You're looking at this region and that region, right? Now, if you wanted to find the total area right there, you have to be very careful because what is going on in this example? Remember, this is cosine x, and this is sine x. So if you were to write an integral expression, what are you going to have to do?
You have to do the area that is not being, or minus that blank area.
Kind of, but it's going to be the same amount of work as finding it directly. How would you find the area of this region right here? Someone tell me what that integral is going to be. The integral from, I'll get you started, 0 to what? Pi over 4. Sine equals cosine at pi over 4. And what are we integrating? Cosine x Yes, exactly. Dx. No, but what about for this one right here?
Then that would be
Pi over 4 to pi over 2 of...
sine x.
Yeah, so what was the key thing that's different about this one?
You have to switch them.
You have to switch which one's above and which one's below. Pay attention to that. Pay attention. A really easy way to get this one wrong is to do what?
Do not switch them.
Not switch them, just integrate from 0 to pi over 2. Would that be correct? No, you'd probably get something close to 0, and then it would be really wrong. Does that make sense, everybody? So pay attention to which one is up and which one is down. That's about it on this one. It's a little nasty, but it's not impossible. I mean, this one right here, what's this upper function right here? Is y equals the square root of what? 2x plus 6. And what's this green one? Y equals negative the square root of 2x plus 6. And then the yellow one we have is y equals... You can integrate things like that. You absolutely can. Now, what do you suspect?
Isn't the integral from the up to the point just gonna be 0?
No, it's not.
No, you have to
No.
find when.
Remember, this is not negative. It doesn't matter if it goes below the x-axis. It does not matter. It's the distance from -2 to -3 is still 1. It doesn't matter. So my question is, this is a little nasty. What do you suspect?
You have to take the negative square root of 2x plus 6 and find when it intersects.
Yes, that's one thing you have to do to... I understand. That's what you have to do to solve this one. But what I'm saying is, if this is a little nasty, what do you suspect? There's a simpler way. Everybody turn your head 90 degrees to the right. No. Tilt it 90 degrees to the right. Tilt it 90 degrees to the right. You do not have to integrate with respect to x. You can integrate with respect to y. Yeah, like that. So now, this one is the upper function, and this one is the... So can you do this with one integral, and is it much easier?
Yeah.
Yes. Put everything away except the pencil, please.